Greetings to all teachers. On behalf of my group, I will be explaining to you the electrolysis process of this setup through this presentation. In this setup, there are 4 electrodes. Electrode A, which is made up of impure copper. Electrode B, which is made up of copper. C, made up of platinum, and D, made up of metal M. Electrode A is situated in a beaker containing aqueous copper nitrate together with electrode B. Electrode C is contained in another beaker filled with concentrated aqueous chloride of metal M together with electrode D. Electrode A and electrode D are connected, and electrode B and electrode C share another connection. Electrode A would be the anode and electrode D would be the cathode, and electrode B would be the cathode and electrode C would be the anode. Firstly, the copper that is contained in impure copper at electrode A, which is the anode, undergoes oxidation to produce copper 2+ ions and negatively charged electrons. For every mole of copper that is oxidized, 1 mole of copper 2+ ion and 2 moles of negatively charged electrons are produced. The negatively charged electrons will then be transported through the wires of the circuit to the cathode, which is electrode D. The M3+ ions that are contained in the solution of concentrated chloride solution of metal M would be attracted by the negatively charged electrons at electrode D. Upon contact with electrode D, M3+ ions would undergo reduction to produce metal M. For every M3+ ion that is reacted, 3 moles of negatively charged electrons would be reacted together. The solid metal M, which is produced, would be coated on electrode D. Moving on, the chloride ions, which are contained in the concentrated chloride solution of metal M, would undergo oxidation at electrode C, which is the anode. For every 2 moles of Cl- that are reacted, 1 mole of Cl2 gas would be produced with 2 moles of negatively charged electrons. The negatively charged electrons that are formed would be transported through the wires of the circuit to the cathode, which is at electrode B. Then, the copper 2+ ions, which are found in the other beaker containing copper nitrate solution, would be attracted to electrode B by the negatively charged electrons that are held there. Upon contact with electrode B, Cu2+ ions would undergo reduction to produce copper metal. As chlorine gas is less dense than air, it would be collected through upward displacement. As the beaker contains aqueous copper nitrate solution, there will be water molecules contained in the beaker as well. However, this reaction will occur as copper is situated below water in the reactivity series and hence allows copper 2+ ions to be reduced preferentially instead of water. The copper metal that is produced through the reaction would be coated on electrode B.